Intermediate algebra for statistics. Rate of change. Lesson objectives. Calculate the rate of change of a quantity. Lesson objective. Formula for the rate of change and average rate of change. Suppose that a quantity y changes steadily from y1 to y2 as the quantity x changes steadily from x1 to x2. Then the rate of change of y with respect to x is the ratio of the change in y to the change in x, given by our slope formula here. Change in y divided by the change in x. If neither quantity does not change steadily, then the preceding formula is the average rate of change of y with respect to x. The units used to describe y per units used to describe x. Per means to divide, so this is just like our slope formula. It's the change in y divided by the change in x. But this time, in word problems, we may just be given units, and that will tell us what the y or the dependent variable is, and will let us know what the x or the independent variable is. Let's do an example. The number of mining fatalities in the United States declined approximately steadily from 85 fatalities in 2000 to 51 fatalities in 2008. Find the average rate of change of the number of mining fatalities per year between 2000 and 2008. Solution. Fatalities per year tells us the units for the y and the units for the x. So this is going to be our change in our y. This will be our change in our x. So we have 51 minus 85 over 2008 minus 2000, which gives us a negative 34 fatalities over 8 years. And if we take negative 34 and divide it by 8, we see it's a negative 4.25 fatalities over 1 year, per year. So the average rate of change for the number of mining fatalities was negative 4.25 fatalities per year. So what does that negative number mean? It means that the number of fatalities had an average yearly decline of 4.25 fatalities. Example 2. The total cost of 12 karate classes and an enrollment fee is $158. The total cost of 20 karate classes and the same enrollment fee is $230. The charge per class is the same regardless of the number of classes for which you pay. Find the rate of change of the total cost with respect to the number of classes. We're looking at the total cost and we're looking at the number of classes. Since we know the charge per class is the same, and that tells us that the rate of change is constant. It's the same. So we can figure out what this rate of change is. So we have the change in total cost. That's our y variable. Our dependent, our independent is the number of classes. So the cost depends upon the number of classes. So we have $230 minus $158 over 20 classes minus 12 classes. This gives us $72 for 8 classes, and if we divide 72 by 8, we see the rate of change is $9 over one class, or per class. So the total cost is $9 per class. So basically each class costs $9. Increasing and decreasing quantities. Suppose that a quantity P depends upon a quantity T. So P would be the dependent and T is the independent. If P increases steadily as T increases steadily, then the rate of change of P with respect to T is positive. As P increases, T increases. If P decreases steadily as T increases steadily, then the rate of change of P with respect to T is negative. As T increases, P decreases. Slope is a rate of change. The slope of a linear model is the rate of change. As we'll see, if we have a linear model, the rate of change will be constant, same as our slope. Let's look at an example. Suppose that a student travels at a constant rate on a road trip. Let D be the distance, measured in miles, that a student can drive in T hours. Some values of T and D are shown in the table. Number 1, create a scattergram, then draw a linear model. Number 2, find the slope of the linear model. Number 3, find the rate of change of the distance per hour in each of the given period. Compare each. For this one, we'll look at 2 and compare them. So solution, we draw the scattergram and draw the line that contains the data points. We can see that the line goes through each and every point. Number 2, use the formula for slope with variables D and T. Here's our slope formula. If we substitute in the variables D and T, we have D2 minus D1 over T2 minus T1. So if we use the points 3 and 150 and 4 and 200, we have the slope being 200 minus 150 divided by 4 minus 3, which is 50 over 1, which is the same thing as 50. So the slope is 50. Number 3, calculate the rate of change of the distance with respect to time from t equals 3 to t equals 4 gives us the change in distance, 200 miles minus 150 miles, divided by the change in time, 4 hours minus 3 hours. We get 50 miles over 1 hour, which is 50 miles per hour. So the rate of change, 50 miles per hour, is equal to the slope of 50. Now if we pick a second set of points, say when t equals 0 and t equals 5, we have the change in distance, 250, minus 0 over the change in time, 5 hours, minus 0 hours. We have 250 miles over 5 hours, which is 50 miles per hour. And again, this is equal to our slope of 50. If there is a linear relationship between the quantities t and p, and if p depends upon t, then the slope of the linear model is equal to the rate of change of p with respect to t. Constant rate of change. Suppose that a quantity p depends upon a quantity t. Then if there is a linear relationship between t and p, then the rate of change of p with respect to t is constant. That means it stays the same. If the rate of change of p with respect to t is constant, then there is a linear relationship between t and p. So the slope is the rate of change, and it stays the same for a linear relationship. Thanks for watching.